Hello, welcome to this presentation about sigils. Once you know them, you'll love them in the Raku Programming Language. But first, a little bit about myself. I got involved with Raku during the announcement meeting in 2000. I actually wrote some specifications in 2005, thanks to Audrey Tang. I got involved again from 2012, after being away from the project for about 7 years. Initially for documentation only, then I actually became a core developer from 2013 onwards, and I'm writing a weekly blog about Raku since 2015. So what is this presentation about? Well, it's about sigils and twigils, and this is what makes Raku different from other programming languages. And while looking at them, I'm going to introduce you to some strangely consistent features of Raku, more or less like a teaser, inviting further research by you. And finally, for those who dislike sigils, I'm going to introduce a way to write procedural code almost without them. And all of this is part of a little cinematic experience. So, what is a sigil anyway? A sigil is a symbol affixed to a variable name, showing the variable's data type or scope, usually a prefix, as in $foo, where $, is the sigil. This is a definition from Wikipedia. It actually comes from the Latin sigillum, meaning little sign, a sign or image supposed to have magical powers. So what are the 4 sigils of Raku? Well, let's introduce the main cast for this presentation, which is the $, the @ the %, and the ampersand. So here you are, the 4 sigils of Raku. So let's have a look at the first one, the $, aka the scalarizer, aka the item maker, aka the one-trick pony. So let's suppose we want to create a lexically scoped variable with the name foo and put a value 42 in it. How does that look? It looks like this. We have a lexically scoped variable, that's what the my indicates. We have a variable with the $, with the sigil $, with the name foo, and we use the equal signs to put the value 42 in it. So what does this display? This doesn't display anything because it doesn't output anything. Anyway, so $, is for single objects. In Raku, everything is an object, or can act as one. When defining variables with the $, sigil, it binds to a container in which one object can be placed. And this is what we usually call a scalar variable. The container is what makes the variable mutable, but the container is also invisible when you're just using the value. So there's something in there that you usually don't see, but you should realize that it's there. It will actually help your understanding of how Raku works. So what if we want to print a string with $foo interpolated in it? Well, we print using say. We have a string between double quotes, and we just interpolate $foo in it. And what is the output of this? The answer is 42. So double quoted strings in Raku interpolate. You can use, you can also use the magic quotes and another selection of quotes, but I won't go into them right now. But they are basically just syntactic sugar for the QQ operator that allows more control in handling the interpolation. You can specifically say, I do not want to have scalar variables interpolated into this string, which can be handy if you have a lot of texts with dollars in them. And of course, say is just short for print with a trailing new line. It saves you typing 2 characters each time, and you don't need to add the new line. So what if we want to create a subroutine named bar, taking a single argument to be placed in the scalar variable? It looks like this. Sub is used in Raku to create a subroutine. The name just specified after that, and then between parentheses any arguments that you want to have. And in this case, we just want to have a single scalar argument, which will be collected into the $foo scalar variable. So how does this look? Not unsurprising, the answer is still 42. Parameters in a subroutine signature are by default bound to the value of the argument that is passed. So you can either create a new container for it, so you can actually mutate the value inside the subroutine by using isCopy on the variable, or you can force the argument to be a container by isRW, or you just don't care and you can say isRaw. Okay, well, that's enough about the dollar, the scalarizer, the item maker, or the one-trick pony. Let's have a look at the @sign. The I call the serializer, or the array maker, or the positionalizer. So what if we want to create a lexically scoped array with the name scores and put a list of values in it? It looks like this. We have an array because we're using the @sign here as a sigil. We give the name, scores in this case, and we put a list of values in it. That's it. So what does this display? Again, this doesn't display anything because we don't output anything. So a sequence of objects is what you actually get when you create define a variable with the @sigil. And you actually create an array object, and it has containers in it, and that's where the objects are put in. It's what the containers is what makes the array mutable. And the containers again are invisible if you're just using them. And maybe of note here is that the comma is what actually created the sequence of objects. So what do we want to print the first element of an array interpolated in a string? That looks like this. Note that you can use the square brackets there to index into the array and put the element there that you want, and the first element starts at 0. And that's the array. There you go. So what does this show? The score is 42. So when you're interpolating with an @sign, they must be followed by square brackets, even if you want all elements, because what would happen if you had something like this in your text, send mail to bugs@raku.org? That would actually just try to access the @Raku array, which probably doesn't exist, which would create an execution error or a compilation error. So what if we print the last element of an array interpolated into a string? It looks like this. Note that you cannot actually use negative indices while trying to index into an array. You can have a notation for that in Raku is a *-1. The star you should think about as the number of elements in the array. So basically you're saying number of elements -1, which basically means that you get the last element of the array because we start at 0. So what does this show? The last score is 314. So what we'd want to iterate over an array scores, putting each value in a variable score and printing that. It looks like this. Iterating over something you can do with for. The array scores we specify there, and we can specify the variable that it should be put into with the -greater than or a little arrow sign, and you will print that. So how does that look? It looked like this. So about iteration, the for keyword allows you to repeatedly execute code on the source of values, which in this case would be an object doing the iterable role. The default variable bound on each iteration is $_. So if you don't want to specify any variable that you want to put your values in, you can just use $_. Arrays do the iterable role, so you can easily iterate over them. And other keywords for repeating code are while, until, loop, repeat while, and repeat until. So what if you want to create a subroutine that takes a single array argument and prints the whole array? It looks like this. We accept the argument there in an array, which means that you have to specify an array to get there, and we print it whole by just specifying nothing between the square brackets. And how does that look? Note that it just will put spaces between the elements so you can more easily read them. So the @sign allows you indexing by number. It indicates an object doing the positional role. It allows indexing with the square brackets. Negative indexes are not allowed in Raku, but asterisk -1 is. And the absence of indices means the object itself. And you can iterate, and when you iterate over it, it will iterate over its elements. So there you go with the serializer. So now have a look at the percent sign, aka the hasher or the map maker or the associator. So what do we want to create a lexically scoped hash, aka associative array, with the name scores and put a list of keys and values in it. It looks like this. Hash because of the percent sign. Again, the name of the variable that you create. And here we put a list of keys and values in it. Now you notice there that we don't actually just have commas there. We also have another symbol there. And that symbol is the fat comma. It basically creates pair objects. And the left-hand side of the fat comma is automatically quoted. It creates a pair object. So you can actually see, think of a hash as a randomly ordered list of pairs. So what if we want to print the score of UE? How does that look? Well, basically we index into the hash by specifying the string there. And that's how it looks. So what if we want to create a subroutine that takes a hash with scores and a scalar with a name as arguments and print the score of the given name? It looks like this. We accept a hash, we accept a name, and we print the score of the given name. So in the first case, we just show the name, and in the second case, we use the name to actually index into the hash. And that's just how it looks. So percent is for indexing by key. It indicates an object using the associative role. It allows indexing by string with pointy brackets. It allows indexing by expression with curly brackets. If you don't specify any indices, it means the whole thing. And if you iterate over it, you get the pairs of which the hash exists. So this is about the hasher. Now, let's look at the ampersand. The ampersand is special in the sense that you usually don't use it that much, but it is important to understand its functioning. So I call it the invoker or the submaker or the callabilizer. So what if we want to declare a variable that can contain a subroutine randomly selected from two other subroutines and print the result of calling that? It looks like this. We declare a variable. Note that we use the ampersand as a sigil. We randomly select from two subroutines. Note that we refer to the subroutine here with the ampersand. If you wouldn't put the ampersand there, it would actually call these subroutines, and that wouldn't work because you would have to specify a parameter for it. And we print the result of that. So how does that look? Well, you get either 43 or 52. I can't tell, it's random. So what about this random selection? Well, the roll method takes a random value from an object. This could be a list, this could be an array, this could be a hash, could be anything, really, as long as it has a roll method. The bool is the enumeration of true and false. Basically, you could think of it as a list of two elements, namely true and false. The ternary operator, the double question mark and double exclamation mark, returns the first value if the condition is true and the second if the condition is false. And note that you don't actually need to specify the ampersand there to call a subroutine in a variable. You can just use the name, like you would with a sub. So what do we want to declare a subroutine that takes something callable as an argument and print the result of calling that? It looks like this. Note that we use the ampersand sigil here to indicate that we want something callable, and we print the result of calling that. Again, if you want to call a subroutine inside an interpolation, you have to specify the ampersand there to indicate that what follows is a subroutine name. And you have to actually put parentheses there. So that was the result. On the interpolation of ampersand, as I said, it will return the value returned by the subroutine. It will interpolate the value returned by the subroutine call. It must be specified with parentheses to cause interpolation, even if the subroutine actually doesn't take any parameters. Because suppose you have a text like this: Ben and Jerry have the best ice cream. You don't want to actually want the executor look for a subroutine called Jerry that you probably don't have and cause an execution error. So what do we want to declare? A variable for a callable and print the result of calling that. Now, here we have a special case of a callable. If we say *-1, we actually create a callable, similar to the -1 subroutine that we saw earlier. And we can actually call that. And it looks like that. So the ampersand is for limiting to code. It indicates that you want to have an object doing the callable role. Subroutines are callables. The body of a for loop is a callable. **-1 is a callable. And if you want to really find out what this is all about, look up whatever currying. Well, actually, whatever currying. The emphasis there is important. So this is about the invoker, the submaker, the callabilizer, aka the ampersand. So if we look at these 4 sigils, then we realize that each of these sigils has its uses. Each sigil signals some behavior, and each sigil indicates some kind of constraint. So enough about sigils. Let's have a look about twigils. So what is a twigil anyway? Well, we use the term twigil as a wordplay on the word sigil to indicate that it uses 2 symbols in front of an identifier. The second symbol placed between the sigil and the identifier. This is actually a definition more or less defined by our good Larry Wall when we actually introduced the twigil. So we have the 4 sigils of Raku, but we also have a support cast of the sigils. We have the twigils of Raku. Now I'm going to only look at 3 of them. There are more twigils, but you generally don't use them that much. So that's just for special cases. So here they are, the asterisk, the period, and the exclamation mark. So have a look at the asterisk. The asterisk is the dynamizer, or the whatever maker, or the lookup upper. It's basically, so what do we want to have? The value of the environment variable user. It looks like this. So note that there's a hash that is available to all of your programs, but it's a dynamic hash. So that's why it has the asterisk in it. And it has the capital letters ENV for environment. So how does this look? Well, for me, it looks like this. On %*env, it actually shows you the current set of environment variables. Like other dynamic variables, they can be set lexically, and they default to the environment variables that the operating system has, that you work, that your environment has at startup. So what do we want to declare? A dynamic variable in a scope and have a subroutine print that dynamic variable. It looks like this. We actually have a dynamic scope there, a dynamic variable in a scope. Note the curly brackets there indicate a scope different from the others, a deeper scope. Have a subroutine, call that, print that dynamic variable. So how does that look? Well, for me it looks like this. Note that the one in the middle is different from the ones on the outside. It basically switched back to the dynamic variables that was on the outside when we're out of the inner scope. $CWD is the current directory in the current thread in Raku. It's needed to avoid race conditions on file accesses, because and then it basically applies to all I/O operations used for relative paths. So if you want to change your current directory, it's as easy as changing that dynamic variable. And it defaults to the operating system's current directory at startup. Now, so Raku does not have the concept of a current directory as far as the operating system is concerned. It just basically puts that in front of any relative path that you are going to use in any I/O operations. So these are examples of the dynamizer. Of course, you can create your own dynamic variables if you want to create very nice libraries. The system itself uses dynamic variables quite a lot, for instance, in gather and take, and the react and whenever structures. But you won't see them because they're internal, but they're very handy to use. So let's have a look at the next twigil, the period, aka the methodist, the call initiator, or the selfie taker. So what should we do if we want to create a class that has a public attribute? Well, it looks like this. We create a class with the class keyword, and we create a public attribute with the has keyword, and make sure that we have the period as the twigil. Of course, this doesn't do anything, so we don't have any output for this. So if you want to create your own class, you can use the class keyword. Well, that's very simple, isn't it? If you want to create a class with an attribute, you can use the has keyword. And public attributes automatically have an accessor method created for them. That's why they're public. And a new method is available to all classes by default, so you actually don't have to specify a new method. And you can set public attributes with named arguments to the new method. So how does it look to create a class that has a public attribute, create an instance of it, and show its name? It looks like this. We call .new. Note that we actually use a dot here as well. So that's why we call it the invoker. And we specify the name of the cat. And we show it inside the double quoted string. So that's how it looks. So if you want to interpolate objects into a string, it will call the string method on it. Interpolating a method call must be followed by parentheses, just like with a subroutine call, even if the method does not take any parameters. So that's not different from actually doing a subroutine call, but it basically makes sure that it does what you want instead of something else. So what if we want to create a class that has a public attribute with a default value, create an instance of it without giving a name, and show its name? We can actually do that by specifying a default value by just saying, okay, it's equal to this if I don't specify it. And we create an instance without giving a name. Well, we just say .new, and that's it. And what would that show? Well, it would show that the name is Spot. So that's why we call the period twigil the methodist, the call initiator, and the selfie taker. So now let's have a look at the final twigil, the exclamation mark, aka the privatizer, the invisibilizer, or the no. So what if we want to create a class that has a private attribute and a method using that attribute? Well, here we have a private attribute. Note that we use the exclamation mark as a twigil. And because it is a private attribute, there's no method then automatically created for you. So you can't call the .then method on this object. But we can create another method with the method keyword and actually use that private attribute inside that method and then call a subroutine, call a method on it. And in this case, I'm going to call the date on it. The default value that we specify there is what the private attribute will get as a value if we create the object. Since we cannot set it with the new, so this will always be the value that it will get. And now is a function in Raku to actually get the exact instant at this moment. So how would this look? Well, it won't look because we don't actually output anything. So how would it look if we actually create an instance of it and show when it was created? It looks like this. We create an instance of it. We don't have any parameters to it, so we can actually just say .new. And we call the method created with the parentheses in there. And how does that look? Well, on the day of this presentation, it would look like this. So that's about the privatizer, the invisibilizer, or the no-knower, aka the exclamation mark twigil. So each twigil has a precise function, and each twigil indicates some kind of scope. So those were the twigils of Raku. Now we have the antagonist, the anti-sigil. Any good movie should have an antagonist. So here it is. And the anti-sigil is the backslash, aka the backslasher, the binder, the equalizer. Sorry. So what I want to create a constant named answer and show its value. It looks like this. The constant is created by using the backslash as the sigil, and answer is the name of the constant, and we can show its value. Now, if you look carefully, it's not that easy to actually show something that has no sigil in a double quoted string. So we have to do something here with the tilde operator. And the tilde operator is basically what we use in Raku to concatenate strings. Objects that are not strings will have automatically called the stir method called on them. And the reason for using the tilde is that it looks stringy. This is from the mouth of Larry Wall. The absence of a sigil, as you may have seen, makes it hard to interpolate. So what if we want to actually create a constant named answer and show its value? Well, there's another way of doing that, and it's in a double quoted string by using the curlies. And again, that's how it looks. So you can actually use curlies in interpolation, and the use of a curly inside an interpolation indicates that there is code in between. Any simple or complicated expression is allowed in there. Even multi-line expressions are also allowed. And the last value of the expression that you have in there will be interpolated. So that's how you can do that without a sigil. So if we want to create a subroutine that accepts a sigilless argument answer and show its value, it looks like this. Again, you can use the backslash in the signature of a subroutine to get a sigilless local constant. So if we want to create a sigilless variable bound to an array, and that array, of course, can be changed. It looks like this. Just use the backslash sigil again and make sure that we have an array pointing to it. You can use the square brackets, the circumfix square bracket operator to actually create an array in Raku. And we can change it, as we can see there. So how does that look? It basically added another element, number 3, with the value 99. So what if we want to create a sigilless variable bound to a hash that can be changed? It's the same thing, but you use the curlies to actually indicate that you want to have a hash. And of course you can change it, and you can index it into it by string by using the pointy brackets, and you can index it to by expression by using the curly brackets. How does that look? It looks like this. So, what when you want to create a sigilless variable bound to a containerized value so it can be changed? Well, that's a little more tricky. It looks like this. We actually need to create a variable with a container assigned to that, and then basically bind to that. And we can actually change that. But yeah, it's a bit meh. So there is currently no syntax to create a container with a value in it. Future versions of Raku may actually have such a syntax, but we don't know about it yet, and we haven't decided on that yet. But of course, you can create your own syntax now. I mean, yeah, it's Raku. You can do basically anything you want. So how would that look? Create a subroutine that will not decontainerize its return value and return a container with the value given. It looks like this. We actually specify the sub with the isRaw trait, and we put the trick that we just saw there with the extra nameless variable inside the subroutine. And of course, this doesn't show anything, but if we want to actually show that, we can just call the containerized subroutine. So basically, we have created syntax here for creating a containerized value. As you can see, it can change it. So that's about the backslasher, aka the binder, aka the equalizer, the anti-sigil. So getting back to sigils. Sigils allow for string interpolation of objects into your string. It also allows the naive reader of your code to see that a variable is actually being interpolated and it's not something else. And so it actually allows you for more compact code, and it basically would help you maybe in a few years' time when you're actually trying to read that code again. Sigils also basically allow the compiler to spot logic errors at compile time and spot logic errors at runtime. And basically, it also allows the runtime to actually create better optimizations. For instance, if a variable is known to have to contain something callable, when you call something in that variable, we don't actually need to check if that something in there is something callable or not, because the type of variable guarantees that there is something callable in there. So what if we want to actually call a subroutine that accepts a positional with an integer constant? So we have a subroutine from negate that accepts a positional, an array, that will become an array inside the subroutine, but we call it with an integer constant. So would that work? No, it does not work in Raku. It would be a compile error, because the compiler can actually determine that the constant int will actually never match the array. So you actually get a compile time error, which can be very useful in Raku or in a programming that language that you have, but the fact that it comes at the compile time saves you a lot of time. But sometimes the compiler cannot do that check. It basically, for instance, if you want to pass a variable to a subroutine, that can be an integer. The variable could also contain an array, so the compiler does not know at compile time what it's going to be. So how does that look? It looks like this, and this will become a runtime error. It will basically tell you that the type check, when binding to the parameter at array, expected a positional, but it got an integer. And it will tell you where exactly this went wrong. So it helps you with, helps the compiler, helps you with readability. And I think once you're used to seeing sigils, they help you in understanding the code. And I mean, there are little signs that can have magic for you once you're sensitive to them. So you too can have magical powers in programming. And this brings us to the end of this presentation. And in good cinematic history, we show the main cast, the dollar, the @ sign, the % sign, and the ampersand. We show the support cast. In this case, they were the asterisk, the period, and the exclamation mark. And we basically note that it was lovingly brought to you by 900 plus contributors in over 22 years. So there we are. I will be taking questions in real time because this was a recording. But if you are looking at the recording, you maybe want to look at the documentation that we have on Raku, or questions that are being asked on Stack Overflow. So you can ask your own question there, or maybe find an answer in the questions that have already been asked and answered. You can ask a question on the Rakulang subreddit. You can actually ask questions on the Raku channel on libera.chat. And we actually also look at the Rakulang tag on Twitter. So if you have any questions, you can also, if you're using Twitter, you can also ask it there. Other useful links are raku.org, which is our main site. Raku.land shows modules in our ecosystem. The rakudoweekly.blog, which is our weekly blog about news from the Raku world, specifically for the Rakudo compiler. We have the Comma IDE. If you're a fan of integrated development environments, you should have a look at Comma, because that's the Raku IDE of choice. And if you're looking at creating web services, you would probably also want to look at Crow, which is a web services toolkit written in Raku for your convenience. And we have a RSS feed collector called planet.raku.org, which shows up interesting blog posts by people on the RSS feed. So thank you for watching, and hope to see you sometime again at a real conference. Take care, stay healthy. This isn't over yet, so be careful. Bye-bye. Hello. I'm here to take your questions. Maybe I should just... Okay, I guess the first question that I didn't answer yet on the chat was, why is there no love for Perl 6 users at Perl.org mailing list? To be honest, I completely forgot about it because, yeah, I don't follow the mailing. I'm not on the mailing list anymore. No, that's not true. Actually, I'm on the mailing list. Anyway, I just forgot. I guess in any next version, I'll put it in there. Hopefully, it will actually get renamed by that time. Okay, I guess I'll just go back to all the questions that people have asked on the channel, on the chat. What is the general term to refer to Raku programmers? Raccoons. Personally, I like raccoons. It's what we use on the Rakulang Reddit. Yeah, there's that. I mean, Raku monger, meh, that doesn't sound right. So, yeah. Raku rollers are being suggested. Well, I guess, yeah, if you're more musically inclined, that would make sense. So regarding say being short of a print or put short of a print, actually neither are the same. Neither actually. They are all different, basically. Say calls the gist method and puts a new line after it. Put calls the string method after it. And print just doesn't do anything. Yeah, I'm not sure if I see any questions, hands raised.
Liz, I raised my hand and I have a question.
Okay, there you go.
Can you talk a little bit about using the same symbols that we use for sigils as like contextualizers so that you can have, hash, ampersand, variable name, or rather hash at symbol variable name, so that you're still using the sigil, but you're using a different sigil as a contextualizer before it?
Yeah, I the thing is, in the previous version of this talk, I actually mentioned it for using it as a contextualizer, and then I found out that, and actually during making that presentation, I actually changed the core to actually make it more sensible in my book. It didn't break any spec tests, but it broke some modules in the ecosystem. And so I referred to that. And so I sort of chickened out on that, on the contextualizer thing because I don't think that the behavior at the moment is completely consistent.
Oh, okay. I didn't realize that.
Yeah. So, I mean, you can put a dollar in front of, you can put, say, dollar parens open, value parens close. And you might think that it actually creates a container, but it doesn't. Whereas if you put an @ sign, parentheses, put something in between, it does create an array. And if you do the same with a hash, it does create a hash. So I found that to be inconsistent. And yeah, I think this is a matter for further discussion. And so I didn't want to touch on it in this, what I consider to be an introductory talk. Does that answer your question? Okay. Any other questions? I guess Andrew needs to okay that or something. It's not something I can do. Question on the chat is, if Raku didn't have sigils and twigils, how do you think these could be replaced by something else in the language? Well, I guess if we're talking about twigils for attributes, I guess they could be another trait on the attribute definition. If you're talking about, yeah, I mean, you can already program without sigils, as I showed. So the only problem I really see is with some of the twigils that you somehow need to replace by traits. Anybody else for questions?
Yeah, Liz, I had a question about Slurpee twigils. The @ sign followed by the star is different from the star followed by the @ sign, and
Yes.
that might be confusing for somebody who's starting in the language.
Yeah. I'm not sure if we consider that use of the asterisk as a twigil.
Okay.
It basically is more.
That's understandable. Yeah. Yeah, and I would hope that we could break that out for newcomers.
Yeah. So basically, in that context, it more means whatever.
Okay.
Right.
Okay.
So it basically means, okay, I'll put whatever you give me into an array.
So we can think of the asterisk really as kind of a prefix on possibly a twigil variable, a twigil sigil variable.
Yeah, but that's would have been nice, but there's also meaning in that, and that would actually clash. So that's why it became the secondary thing. So yeah, in my mind, that is more of a modifier on whatever you specify there rather than a twigil. But yeah, you have a valid point there. Maybe I should have mentioned that as a twigil. Good point. Yeah. I'll keep that in mind for the next version. Thank you.
Can you actually do a whatever star followed by a twigil, or is that not allowed?
I would have to try.
Yeah. Okay. Okay. No, I mean it makes perfect sense with using it. I mean, we are talking about basically Slurpees, right? We're talking about like whatever star @args is Slurpee args, right? I mean, I hope I'm using the terminology correctly.
I'm not sure if the star there would actually cause you to create a whatever code. I mean, the rules for that are somewhere in the documentation, and I must admit that I don't actually know the rules by heart. I know that the thing is, you use them for simple things generally, so you don't actually have to put in parens or curlies in places where it's just a simple thing like lowercasing something or doing something simple. So
I think it's very, very powerful using the whatever star @args for slurping things off a command line. I think it's wonderful, but people might confuse that with other twigils that are in common use, which again are your main 4 sigils followed by either a whatever star or a period or an exclamation point.
yeah, it's a valid point, and I probably need to address that in a future version. Yeah.
Great. Thank you.
Thank you. I think we've reached the end of our time. I'm not quite sure, but
yes, actually, yes, indeed.
yeah, 70-50 you said, Andrew. So I guess this is it. Well, thank you for your questions, and I'll be still online on the Raku channel and here to take any more questions if you'd like to.